A really, really common application with anything that is a parabola shape, so anything that has motion. Think about gravity. Anything that's thrown into the air must come down, and it makes that parabola shape. So an application is finding minimum points or maximum points. Anything that's thrown or kicked or tossed up into the air will have a maximum point because it'll hit the top and then it'll come back down. And so when you have the function, so if you look at this definition, when you look at the definition here for minimum and maximum, you're using this generic form, so it's not the standard form with the parentheses, it's all multiplied out. The vertex can be found by using negative b over 2a. Now you hopefully think that this sounds familiar because this is how you found your axis of symmetry when we worked with these in intermediate algebra and algebra 2. So this would be the x value, and then if you substitute that into your function, that would be the y value. So we're still going to use negative b over 2a here to help us find our minimums and our maximums. So if your a value is greater than 0, which means your parabola looks like this, it has a minimum point, right? If your a value is less than 0, it means your parabola looks like this and it has a maximum point. That's the only difference there. You find those values the exact same way. You calculate negative b over 2a, and then you substitute it in to your f of x function. So let's go ahead and practice that here. The maximum height of a baseball. The path of a baseball after being hit is given by this function. So we'll use that. F of x is the height, and x is the horizontal distance from home. There's two questions here. What is the maximum height of the baseball? So what's f of x at the maximum? And how far away will the baseball land? So from home plate, which is your x, how far away will it land? So let's just kind of sketch, and I don't have any exact values here, but if I start at 0, I know the baseball has to go up and then it has to come back down. Okay, so if we're starting at 0, it's at the maximum point here, and then it lands over here. So the picture just kind of helps us figure out what we want to find. So to find the maximum height, we're going to use what's in the table above. And we're going to find the x equals negative b over 2a. So in this case, our a value is that long decimal. Our b value is just 1. So this would be negative 1 over 2 times negative 0.0032. So that gives us the x value of the maximum to be 156.25 feet. Now that's the x value, that's going this way. So this is 156.25 feet. I want to figure out what is the height at that point. So what is this value? What's the height? That would be taking this value and substituting it into our equation. So if we do that, we'd have f of 156.25 I need to write this down below, sorry. This program isn't quite as user-friendly as Notability where you can move stuff easily. So I'm just going to erase, and then I'll write it right below. So it'd be negative. So if we type that all in your calculator, you get 81.8125 feet. Oh, sorry, 81.125 feet, and that would be the height at that point. So the maximum height, what is the maximum height of the baseball? The max height is the 81.125 feet. Okay. Now it also asks us to find how far away the baseball will land. So we want to figure out this ending point. Well, that's one of our zeros. So the end is a 0. So we need to take this function and find the zeros, and anytime there's a decimal or a fraction or anything like that, I go directly to the quadratic formula. So if we do our quadratic formula here, we'd have x equals the opposite of b, so -1 plus or minus our square root of b squared, which is 1, minus 4 times a times c, which is 3, all over 2 times a. So let's use our calculator in a couple spots. Let's use our calculator to figure out what would be underneath the square root, and then also to figure out what would be in the denominator. And then we can figure out what the two zeros would be, the two x values, because there's a plus and a minus. So we would keep x equals -1 plus or minus the square root. And then if we type all of that in our calculator, it'll give us 1.0384. So go ahead and do that and double check. Make sure your calculator is giving you the right answer. You're typing it incorrectly. And then if we do the denominator in our calculator, 2 times that decimal gives us -0.0064. Okay. So now this will give us two answers because we have one positive, one negative. So if you type this in your calculator as -1 plus the square root of 1.0384 and divide it by that fraction, you will get the answer. Let me write it out. So if you type that in your calculator, you get -2.97. Well, in terms of a distance, negative doesn't make sense. So what that represents is that's where your ball hits in the back. So what that means is there was a height of a person throwing the ball, which makes sense, right? We don't throw the ball from the ground. We throw it from wherever our arm is. So that is our backwards 0. So if we do -1 minus the square root, and then divide it by the denominator, we should get 315.472. That's our positive 0. So that's where our ending would be, which makes sense if you think about it for what we already found. We're at 156 about in the middle, so 315 makes sense for where it would be at the end. So our question says, how far away will the baseball land? So let's answer right next to this answer. The baseball will land 315 points. And then pay attention to how the problem asks you to round. Here I'm going to go to 3 decimal places, feet away. And there's my two answers. Okay, you'll be asked to do both of those things in your assignment, which is here, and I have the key written out because you do have some evens in there that I wanted you to cover. And as always, if you have any questions, let me know. Make sure you're showing your work, checking your answers, and figuring it out if you don't get the right answer, or message me.